A NAS is optimized for storing data. In many cases, the NAS is even used as the only storage location for personal files. For flexibility, Synology offers different ways to use both SSDs and HDDs on the NAS. So let's now look at the internal storage media of the NAS. What is the difference between SSD and HDD? We'll start with the HDD. The HDD, hard disk drive, has mechanical components. Data is transferred by magnetic heads, usually arranged on a moving actuator arm, written to or read from the platters. This mechanism is quite sensitive. Strong vibrations during operation or even dropping of hard drives should therefore be avoided in any case. The speed depends mainly on the rotation speed of the platters. Classic hard drive operate platters at 5,400 to 7,200 rotations per minute in home and business environments. Whereby there are also high-performance hard disks that operate at more than 10,000 rotations per minute. HDDs are available in the classic 3.5-inch format or in the smaller 2.5-inch format. 3.5 hard disks are used in servers or desktop PCs and offer the greater storage capacity. 2.5-inch hard disks are usually installed in notebooks or smaller external media. Due to their small format, fewer storage platters can be installed, and the available capacities do not come close to those of 3.5-inch hard disks. Now let's get to the SSD. SSD is the abbreviation for solid state drive. The SSD belongs to the category of electronic storage media, which is similar to SD cards from cameras or mobile phones. Here, the data is written and read electronically on the built-in memory. There are no moving parts, hence the solid state in its name. This leads to a faster access times despite lower volume and lower cooling requirements. An SSD makes sense especially when we need high IOPS. This would be the case, for example, when using virtual machines or large databases. IOPS simply describes the amount of data that can be read and written from memory per second. It has established itself as a standard for evaluating the performance of systems in IT. SSDs are becoming cheaper and cheaper, but are still more expensive than the classic HDD, especially when large amounts of memory are required. How do our hard drives communicate with the NAS after we install them? In terms of hardware, in addition to the question of whether HDD or SSD should be selected, especially in the business area, we also have to ask which connectors should be used. On the software side, protocol families are used here, which are not yet discussed here. For example, when we talk about SATA, we mean both the connector and the associated protocols. SATA drives are widely used and are the most commonly used hard drives in computers or storage. Therefore, many Synology systems are also designed to use SATA HDDs. SAS drives, on the other hand, are able to achieve higher transfer rates due to their controller. They offer parallel control at the same time and are designed for larger business environments. Dual port compatibility allows redundant paths, which is important for dual controllers. Due to their technology, they are always more expensive than comparable SATA drives and are therefore only installed in those scenarios that require SAS. Even if the connections are quite similar, you have to be careful here. SAS hard drives only work in devices that also have SAS hard drive controllers. This includes devices from our SA or Flash Station series. They do not work in devices that only have SATA hard disk controller. Conversely, SATA hard drives can also be installed in most of the devices which have a SAS controller. SAS controllers are correspondingly compatible and can accommodate both SAS and SATA storage media. M2 is an increasingly used space-saving connection type that enables direct connection via PCIe thanks to the NVMe protocol. In parallel, the SATA protocol family can also be used here. An important point is that we can currently use M2 memory only as a SSD cache. SSD cache is a technology that allows files that are accessed regularly to be stored on a faster cache, thus significantly improving read and write speeds. SSDs can be configured as cache, whether they are connected to the system via SATA, SAS, or M2. We have the choice between a read-only cache or read-write cache, which then requires at least 2 SSDs. Once we have configured the SSD cache, we see its status in the storage manager and get detailed information about its usage. When Synology's own SSDs are used, the DSM shows us an exact numbers, and this ensures uninterrupted operation and a maximum service life. So much for the SSD cache. We now come back to the HDD hard drives because especially SATA HDDs are again divided into different categories, which we will go through now. Desktop hard disks are, as the name suggests, designed for classic computer operation, for example, running 5 times a week for 8 hours. NAS hard drives, on the other hand, are suitable for use in storage systems such as our Synology systems, and their advantage is that they are designed for 24/7 operation. This means that they can run around the clock in a RAID in the NAS. NAS Pro hard drives are designed for use in larger systems. The more hard drives we run side by side, the more vibrations are present. Even though this is not directly visible to the user, these micro vibrations can affect the read and write heads of the hard drives. NAS Pro hard drives are equipped with vibration sensors and can therefore compensate for the vibrations to ensure stable and safe use. NAS and NAS Pro are the most common HDD types used in NAS servers. The further we move on the arrow to the right here, the more resistant and performant our hard disks are, until we reach the far right of the enterprise segment, in which the hardware is designed for 24/7 operation under full load. Another category are the surveillance hard drives. These are mainly designed to write data as we find it through camera recordings in video surveillance. So we are talking about scenarios where 70 to 80% of time only writing takes place. Archive hard drives are for archiving, and these are also mostly only written, but are not designed to run in a RAID. When using them here, please make sure that these hard disks run individually. The probability that these hard disks will fail in a RAID and thus cause data loss is quite high. In order for users to be sure that hard drives in the system are running properly, Synology provides a compatibility list. Here we continuously test the most popular hard drives available on the market in each Synology model. Basically, every hard drive is recognized by the system. However, in the long run or under heavy load, problems such as performance degradation may occur. This is a very small percentage, but before buying a hard drive, you should check if the desired hard drive or SSD model has been tested as compatible or incompatible with the system. If a model is not listed, this means that we have not officially tested this hard drive or SSD and cannot guarantee that these hard drives will be stable in the long run. In cases where the use of SSDs makes sense, Synology's own models are the easiest and most reliable choice in terms of compatibility, as they are optimized for our storage solutions. Above each compatibility list, there is also a button for incompatible models in the upper right corner. When we click on it, we get a new list of disks that clearly failed in our performance test and therefore should not be used. Synology's operating system, DiskStation Manager, has a drive monitoring system. This measures various indicators of our hard drives in use and can send us alerts via email or push notifications. These smart tests should always be enabled and performed regularly so that defective drives can be replaced in a timely manner.